Hello, everybody. Welcome back to another live office hour brought to you by Chegg. So today we will be focusing on solving logarithmic equation. So for the people just coming, here's a question for you guys on the board, so you can go ahead and try it. In the meantime, we're just waiting for more people to join us. Remember, we will have a live stream every Mondays from 6:45 p.m. to 7:45 p.m. Pacific time, which is like this time we have to we will go for an hour. And today, we will see. All right. So first person, Henry. Thank you so for coming back again. Welcome back to another live office hour. And like always, if you have any questions that you guys would like me to answer for you, I'll try my best. Today, let's try to keep our topics with logarithmic equations, because last time we did the exponential equations, and 2 weeks ago we did the polynomial equation. So I think today, log equations. All right. Hello, everybody. Thank you guys so much for coming. Go ahead and solve this question first. So this is like a warm-up for today. And like always, if you have any questions regarding your trig or precalculus, feel free to drop them into the chat. And definitely scan the QR code right here so you can check out more things that from Chegg that can offer. Unfortunately, we are not doing calculus. We are doing trig and precal. So I can't. Yeah, FTC, that's a fundamental theorem calculus. Our topic for today, for the live streams, will be focusing on trig and precal. And again, this is like the algebra part of precalculus. I see many of you guys are solving the equation already, and many of you guys are getting it right. So here's the solution. First thing though, unfortunately, we cannot just combine the logarithm right away because they have different bases. But it's okay because we have the change of base formula. This is one of the most important, most commonly used, most frequently used, I should say, change of base formula. Which says if you have log base of some, let's say b, and then let's say the input here is some x. This is just equal to, you can do ln of x over ln b, where ln is the log with the base e, the special number e. And you can also do this as the regular log, which is log base 10 and then x over log b. As long as the top and bottom have the same log with the same base, then this is correct. So our first thing is, let's just use natural log for this and that. So we will get ln x over ln 3 for this part. And then for this, we add ln x over ln 9. And that's equal to 1. Now, as you can see, for the variable part, we have ln x and ln x, which is very nice. Now it depends on how you would like to solve it. Notice here we have ln of 9. We can actually fix it a little bit. This is how I can do it for you guys though. Right here, I will just make another note for you guys. ln 9, which is the same as ln of 3 squared. And then for the square, we can bring that to the front. So we can look at this as 2 ln 3. So in fact, this is just really the same as 2 ln 3. And of course, here we have ln 3 already. If you want to combine them, you have a few ways to go about doing this. Perhaps let's just multiply the top and bottom by 2 so we can combine the fraction. So let's go ahead and do that here. So that we can put them together. They have the same denominator, which is 2 ln 3. By the way, do you guys ever write the denominator down first? Just wondering. Anyways, on the top is 2 ln x plus 1 more. So altogether, this is 2 plus 1. We get the 3 here, and then we have the ln x, and that's equal to 1. Now, we can multiply this to both sides. So this right here will give us 3 ln x equals 2 ln 3. And then I'm just going to put it here. divide both sides by 3, we get ln x is equal to 2 over 3 ln 3. And then finally, we can just do e to this power and e to that power, so they cancel, and then we can get the x by itself. X is equal to e raised to the power of 2 over 3 of ln 3. Well done, kind of. This is a pretty crazy looking power, right? ln 3 and that. Here's one thing though. Do not cancel the e and ln like this right away. We cannot do that because we have a coefficient here. What we will have to do is, we will have to do this but backwards. Instead of putting the power to the front, we are going to bring the coefficient back to the power. So have a look. Take this, put it here. So we get, this is e to the ln 3 raised to the 2/3 power. And you can cancel this out. So finally, x is equal to 3 to the 2/3 power. And for the people who would like to simplify a little bit more, the over 3 power is the same as the cube root. So we can look at this as the cube root of 3 to the second power, which is just 9 inside, and then we have the cube root like that. And I think I did enough. There's no other way to make this answer simpler than this, so I'm going to stop right here. So that is the warm-up for today. Now I will talk to you guys for a little bit. Hello everybody, thank you guys so much for coming. If this is your first time, then welcome. If you have been here before, please go ahead and in the chat, go ahead and drop in me in the chat, so that way I know you have been here before, and welcome back. Thank you so much, I really appreciate it. This is the online office hour brought to you by Chegg. And for more office hour like this, and if you want to see what Chegg can offer you, please scan the QR code right here. We do have office hours throughout the week, hosted by different instructors as well. We have physics, chemistry, and of course, I'm doing the math with you guys. For today, if you have any questions regarding your trig or precalculus classes, go ahead, drop them in the chat. I will do my best to answer as many questions as possible. Let me see who have been here before. Jokic Horse. Hello, hi. Hi. Notice, some of you guys might notice that I'm not wearing my glasses, so that's why I have to get really close in order to be able to read, right? So, hello. Hi, Thomas. Hi, AWS. And let me see. Hi, Robert. Hi, friends. And my name is Steve. Yes, that's correct. Sorry if the message is just like when the messages come, like your message might be pushed down, and sometimes I might not be able to just keep track with everybody's name. I'm sorry. Hello, Gabriel. Hello, everybody. Hi, Joe. Hello. More problem to share, please. Sure thing. This is the first one, but if you guys have questions, you guys can feel free to ask me as well. Remember, this is like an office hour, meaning that you come to your instructor at your school and then you ask the instructor questions. So that's what this is for. And I really appreciate Chegg is doing this for us. That way, I get to host the live stream with you guys and all that. Okay, try this, log 2, log 3, 6. I'm going to do that. So I'm not going to write down the word solve. It's just solving. So this is log 2, 3x plus log 8. 3x, and that's equal to 6. Okay. It will be similar to what we did earlier. So let's go ahead and just do the same approach. Write this as ln of 3x over ln 2. This is ln of 3x over ln 8, and that's equal to 6. Now notice though, let's just put a little note. Actually, I will put down all the notes right here. Note, ln 8. It's the same as ln of 3, just kidding, 2 to the third power. And then bring the power to the front, so we have 3 ln 2. So if you look at this, this is 3 ln 2. So that means right here, we better have this 3 and that 3. And remember, this is a 3 ln 3x, this is 1 ln 3x. Combine the tops together, that will be 4 ln 3x. And the bottom stays the same. We have 3 ln 2, and that's equal to 6. Now the rest is very similar to what we did. Here though, we have some fractions, so let's multiply 4 over 3, which is just the reciprocal of that, and also the ln 2. Perhaps I will try to squeeze in the ln 2 right here as well. And then do the same thing here. So this cancel, 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 cancel. Do not divide it by ln. That doesn't make sense. In order to get rid of this ln, we will have to do the exponential, right? But anyways, this right here we can reduce a little bit. 2 goes into 4 twice, 2 goes into this 3 times. So we are getting, let me put down the work right here. We have ln 3x equals 9 over 2 ln 2. And right here we can put this up here. I'm going to erase that because we don't need to see this anymore. Okay. I still want you to make this like that. So we will have ln of 3x equals ln 2 to the 9 over 2. And then do the exponential both sides. And then 3x is equal to that. So just 3x equals 2 to the 9 over 2. And then divide both sides by 3. So 1/3. And the over 2 is the same as the square root. And then 2 to the 9th power. And depends how you want to do it. If you want to simplify it, go ahead. If not, then that's that. You can also look at this as 4 and 1/2. So 2 to the 4th power is 16. So we can look at this as okay, it's like 2 to the 8. However you want to do it. Okay, I'm just going to write it like this. This is what I have in mind. This is 1/3, and then multiply by 2 to the 4th, and then 2 to the 1/2. Something like this. And then just, that's 16 over 3, and then square root of 2. Yeah, something like that. (16 square root of 2 over 3). Thank you, I got it right too, yay. So that's that. All right, so for today, if you guys have any... Wait, did I write down the question wrong? Let me see. I told you guys I don't have my glasses with... I don't have my glasses on. I can't read well, but yeah, sorry. But as long as the thing put the same, then yeah, that was my excuse. Anyways, good practice. Good practice. Okay, so let me erase this right here, and then if you guys have any questions, feel free to just drop them into the chat. I can see the chat. And yes, this is live for the people who just got here. Welcome. If you haven't been here before, welcome, welcome, welcome. If you have been here before, welcome back. Thank you so much. We're not doing integrations right now. We are focusing on trig and precalc. And today's topic, I want you to focus on logarithm, especially logarithmic equations. Here's a real quick question I have prepared for you guys, so maybe we can take a look. So How would you solve this equation? Let's say we have 3 to the ln x power. It's equal to, let's say, 2. You have two ways to go about doing this. I just want to mention a pretty cool logarithmetic property. It's not that well known, but it's pretty cool. So this one is not so difficult in the sense that if you know how to take the inverse operation along the way, it's not so bad, right? Firstly, though, we can just, let me erase the q, and then let me just give myself more space. We can just take the log base 3 to both sides, and that's fine. You can cancel this, and then you just get log of x, sorry, natural log of x equals log base 3 of 2. And then you can just do e to this power and e to that power cancel, and then you get x is equal to e to the log base 3 of 2. If you box it like this, sure, why not? This is a good answer for that. And this is a good answer for that. And then here's another thing that I want to show you guys. Truth be told, if you look at that, 3 to the ln x equals 2. What we can do is, when we have the natural log in the power, we can actually switch the base. So we can actually swap the base. 3 and x can be swapped. How do we do it? The 3 becomes x, and then the x becomes the 3, and then that's equal to 2. That's pretty cool. And then have a look though. To get x by itself, we are just going to raise both sides to the 1 over ln 3 power, because the reciprocal power. And by the way, this is okay, right? Because we're not doing any like divided by 0 whatnot. And then this and that do cancel out. And then right here, x is equal to that, 2 to the 1 over ln 3 power, just like this. Now, a fun exercise is that if you did it this way, you will get this. But if you did it this way, you will get that. Are they the same? Of course, right? But how would you go from this to that? You guys can think about it. Okay, good question. BB9, why can you swap the base and the exponent? You mean the base and the input of the logarithm, right? Good question. I'm going to answer that. So the question is why we can switch this. But by the way, though, this right here, you guys try it. Go ahead and try. Why is this equal to that? Right? This is one of my favorite exercise with logarithms. And what I will do for you guys right now is to show you guys why this could be done. I really think this is one of the most, perhaps the most underrated logarithmic properties. Here the question is, suppose we have good values a, b, and c. Then why is that? A to the log base b of c is the same as c log base b of a. Why is that? As you can see, we swap the a and c. Right here, let's just assume a, b, c are good numbers, and you can just say they are all greater than 1, and that will be for sure safe. For example, if b is 1, game over. If a is 1, also game over. So assuming they are all greater than 1, then we'll all be safe, okay? Now, to do proofs, we are going to start with the left-hand side and then just end up with the right-hand side. It doesn't really matter which side we start because it's just a matter of swapping, right? So let's start with this. Here we go. Have a look at A. This, I want to end up with base C, right? So what I'm going to do is, I really want to produce a C. But just ignore that. C to what power will give us A? C to what? Well, if you raise that to log base whatever, Well, let's do C and then A. This and that will cancel. We get it back, right? Yeah. Okay. And then no, this is not how I'm going to do it. If I cancel this, I can't do too much with it. And no, what I would do is, sorry, pick another one. I want to end up with C. Here we go. I'm going to do B to the log base B of A power. They still cancel because I still have to have log B and the log B match. So that's the part. And then I'll take this and raise to log base B of C power. We have a power to a power, so we can multiply the exponents. So this becomes B for the base, but I will do log, I'm going to change color. This right here is log B of A times log B of C. Now, what I'm going to do next is, I'm actually going to just do B to this power first, log B of C, and then we raise that to log B of A. Have a look. This time though, we see that the B and log base B of C, right? This and that cancel. So we just end up with C for the base, and then the power is that log base B of A. So this is how you go about proving this. And then for proofs, usually you put the top box and then just shade in and say, hey, we're done with the proof. And of course, if you guys prefer to put down QED, be my guest. Yeah, I was supposed to do that so that the proof will go smooth. If you pick the other one, then unfortunately log base B, in order for this to happen, they have to have the same base in order to cancel out nicely. So that's what I should have done. My first attempt was incorrect. 3 square root of x is equal to ln 3. 3 square root of x is equal to ln 3. 3 square root of x is equal to ln 3. Let me see, 3 to the power of square root of x. Oops, no. 3 square root of x. 3 to the power of square root of x is equal to ln 3. I think that's the question. I think I am reading it right. Again, just because I had to get really close in order to see it. Okay, so to solve x, it's not so bad here. What you can do is just log with the same base 3. I think this is my favorite way of solving log equations. Just go ahead, if you have exponential, right? If you have a exponential equation, the x is in the exponent, you just take log of the same base so that they can cancel, and you do the same right here. So that this and that cancel, and you get square root of x equals log base 3 of ln 3, like this. And then after that, ooh, this is possible because ln 3 is bigger than 1, so this is still bigger than 1, so this is positive, so we can proceed. I should have checked earlier, I should have mentioned that, but it was not a super tricky question, so this is good. So x is just the square of that, and I don't really think there's any like a nicer way to write down this expression, so I'm just going to keep it like that. However, do not bring the 2 to the front though. Yeah, because this is on the very outside. I think there's an interesting question that I wanted to share with you guys because I was just thinking about this. Is it possible to solve 3 to the square root of x equals ln 2? Now this is slightly more interesting. Is it possible to solve this with just real numbers? with just real numbers. Oh, this is still possible, right? Because that's just decimal. No, I wanted to make it not possible. What if, Oh, well, you guys pretty much know what I was trying to do already. How about if I do this? Then, yeah, it's not possible anymore because this is actually a negative number, right? Because this is less than ln1. ln1 is 0. So this is less than 0. 3 to whatever cannot be less than 0 in the real situations. So no real solution for this one. All right, solve x to the a is equal to a to the x. That equation, unfortunately, is a little bit beyond the scope of precalculus. So unfortunately, we will not be able to do that. And let's see. At cheese pie, you have the ln square x is equal to ln of x squared. You guys want to do that one? If you put the x here and x here, I don't think I will be able to solve it. Yeah, but let's do the ln of x squared, and then depending on where you put the x. So have a look. We have ln x squared equals ln of x squared. Now, here's the thing. These two things are very different. This means ln x times ln x. This means ln of x times x. This power can be brought to the front, but this one right here, no. Here, this is ln x squared equals 2ln x. And the best way to solve this, do not divide both sides by ln x, because you might be dividing by 0. Bring this to the other side. And then factor out the ln x. Remember, this means ln x times ln x. For two of them, we are going to factor out one of them. So just like this, and then we have another one, and then we have the minus 2. It's equal to 0. So now, this means this factor ln x is equal to 0, or that means ln x is equal to 2. Put the 2 to the other side. So e to this power, e to that power, either x is equal to 1 or x is equal to e squared. And then we are done. Yeah. Good catch. Good catch. It is true that when you bring the 2 to the front, you should have the absolute value right here. Very good catch. However, because the equation was written this right here in the first place, right? Let me put it here because here we have the QR code. If you guys haven't scanned the QR code, please do so and check out what Chegg has to offer for you guys. Just scan the QR code. And yeah, so have a look. If it's ln x, if it was written like that, it implies x has to be greater than 0. Since x has to be greater than 0, we can drop the absolute value here. But I should have at least mentioned that. So yeah, thanks for pointing that out. I was just lucky that I didn't make a mistake because I forgot to do this. Can I give the upper bound? Sorry, we're not doing calculus right now. We're doing the trig and pre-calc. And today we're focusing on log equations. Do I ever do Cal2 office hours? No, but if you guys click on if you guys scan the QR code, I think we do have other instructors from Chegg that they do calculus too. Calculus or calculus 2 in general. Hello, the mathematician. Thank you. I'm doing good. Thank you. Okay. 3 sine x plus 4 cosine x is equal to 2. Today we're trying to do log equations though. We did do trig equation office hour a few weeks ago. You can go back to that and you can see some of the equations that we did. Let me see. This right here looks hard. Euler God, right? I doubt I can solve that. I don't think I can solve that. Yeah, if I cannot solve the question within, if I don't know. Yeah, and thank you guys so much for coming. For the people who just got in here, thank you guys so much for coming, and welcome to the office hour brought to you by Chegg. Again, if you guys scan the QR code, that will really be helpful. Just check out what Chegg has to offer for you guys. Can you give us a clue to the topic for next time? I haven't decided yet. If you guys have any suggestion, feel free to put in the chat as well. But please put it, and please keep them within trig or precalc. And let's try to do the things that we haven't done before. ln x is equal to cube root of x. For that, we do have to use the Lambert W function. I will tell you though, that's an interesting part right here. Let me just erase this a little bit. Why am I using my hand? I should have used my eraser, but too late. Anyways, ln x versus the cube root of x. I will tell you though, if you are just doing the precalculus method, then you will use your graphing calculator, graph ln x, which will look like this. Right, this is 1, and that's ln x. It has a vertical asymptote. It has no horizontal asymptote. I think I'm going to go over that in a bit as well, because that is quite tricky sometimes. Now, for cube root, I'm going to do it in blue. It looks something like this. Oops. Oh well. Let me try to do it better. It's like this. Kind of, yeah. And then yeah, it's like this, right? It's kind of like this. Like the natural log will take over somewhere right here. Yeah, this is the best I can draw for you guys. It does not have a horizontal asymptote either. Let me try to do it better. Something like this. Okay. Now, how many of you guys think that ln x will be always above the cube root of x after this point? Do you guys think that they will never intercept anymore right here? Maybe far in the future. So go ahead and let me know what you guys think. I see an answer. One is about 6 point something. Yes. In fact, if you wait a little bit longer, when x is about 90 something, this thing right here is going to go up. There's no way for me to draw any good, but I will just write it down. I will say fact. ln x and the cube root of x will intersect again for, and we'll just add x about 9. What was the answer? 90 something, right? 93 something. 93 something. It's actually a pretty interesting precalculus question, because usually in precalculus, we just look at the graphs and then say, oh, hey, we only have one intersection. But no, the truth is, if you make the window big enough, you will see they do intersect again at about 93. And usually this is one of the topics I do go over with my students, and it's almost like not fair. That's why I would usually just tell them, maybe just like try to ask them as a trick question for fun first. So the fact is, power functions, x to whatever power, will always beat natural log, x to some positive power, and x to some positive power. I don't understand volume by cylindrical shell. I'm sorry, we are not doing calculus here. We're doing trig and precalc. So if you scan the QR code, you should be able to find out who will be doing the calculus office hour for the week. Yeah, so go ahead and check them out and make sure you don't miss that. Okay. Random piano videos. X squared minus 8xy plus 16y squared equal to 0. That's a... I don't think I will be able to solve the question right on the spot without like making mistakes here and there. So I'm sorry. And Raymond, the 0 to the zeros, I will tell you real quick though. 0 to the 0, it has no agreement. I think this is the best response I can provide to anyone. And usually I'll just say, let's not even get into the math debate. Some people say 1, some people say undefined, but it's not equal to 0. 0 to the 0, value-wise, not equal to 0. But if you're talking about calculus limit, it could be equal to 0 for the 0 to the 0 indeterminate form. Okay. Tangent of ln of sine x. I don't think that is like nice solvable either. Oh, this is what I was telling you guys earlier. So this is the facts that you should know about logarithms. So perhaps just a quick review if you just started with logarithms. So these are the facts that you should know about logarithms, right? I would just say must know. I think it sounds better. These are the must knows for logarithms. Firstly, if you have a log function, the graph will look like this. And we'll just write this as y is equal to log base b of x. Here though, the b has to be greater than 1. Because if b is like 1/2, the shape is not going to be like this either. And I do have a few things to tell you guys. Notice how here we have a vertical asymptote at x equal to 0. That's one thing. And truth to be told, if you look at this picture, I know my picture is not the best, but if you use your graphing calculator, sometimes the graph might be deceiving. It might look like the graph has a horizontal asymptote, but the truth is, no, it does not, because this right here, I'll just say has no horizontal asymptote. And then perhaps the best way to see it, let me see if I have my paper. Just give me 1 sec. I have my paper here. All right, I'm back. This is how we get the logarithmic functions in a precalculus class. So you guys see that this is the exponential function. It could be e to the x or 2 to the x, like this, right? Now, to get log functions, what we are going to do is just switch x and y, and we are going to do the reflection. So have a look. Hold it, and then you flip it, and then you got you will get a log function. And if you flip back, now have a look. For the exponential function, this right here, we don't have a vertical asymptote. We do have a horizontal asymptote for the exponential. But once you flip it, sorry, let me do it again. You have this. Once you flip it, the horizontal asymptote becomes vertical now, and this right here will keep on going up. So here's the thing. We have vertical asymptote at 0. This thing has no horizontal asymptote, and perhaps I will also write this down. The domain is negative. The domain is from 0 to infinity, and the range, it goes from negative infinity to past infinity, because it goes straight down and then it goes up. Right? It goes up slowly but surely. Right? Slowly but surely. And perhaps this is one of the hard questions that you usually get the pre-calculus students. So I want to mention that real quick. So here's a question. Here's a question about log functions. Let's go ahead and just focus on finding the vertical asymptote, because there's no horizontal asymptote anyways. Find the vertical asymptote for, let's say y is equal to ln, which is just a natural log. And then let's say we have x squared minus 5x plus 6. So this is the question for you guys. Go ahead and think about it first. In the meantime, I'm going to read your answers. I'm going to come here. Perhaps it's easier. Right now we're trying to do this question. Right, this is like fundamentals. Right, we're trying to see how to find the vertical asymptote of a log function. So for this right here, once you know it, you will see that it's actually pretty straightforward. But if you don't know what we are looking for and how, then it's going to be like impossible. Vertical asymptote at 2 and 3. That is correct. Here is what I want to show you. Notice we do have a vertical asymptote. That's when x is equal to 0. If you put 0 in here, it looks like we have log of 0. It's undefined, and the picture is that we have a vertical asymptote. So to find the vertical asymptote, this is all you have to do. Let me just indicate that. VA, you're looking for log of whatever base, and you are trying to get a 0 inside. There are two cases that you have to be worried about for a vertical asymptote. This is one of them. The other one is what we did before with the rational functions. It's when we have a non-zero number over 0, when we have a rational case. But for the log case like this, you make the inside equal to 0, and you will get the vertical asymptote. Truth to be told, I would like to ask you guys this, because I'm not so sure if there's any other exceptions. I don't think so, but usually for the questions that we do in pre-calc, this will be pretty much enough. So, to find the vertical asymptote of this function, all we have to do is to set this equal to 0. And then it's a quadratic. We can just go ahead and factor it. And this right here, x is equal to 2, x is equal to 3. So we have two vertical asymptote at this x values. My only concern is that if the input is slightly more complicated, maybe when you have log base b of 0, you don't get a vertical asymptote. But I don't know how complicated it has to be. I'm not entirely sure. But usually, if you just do this, you can get the vertical asymptote of a log function. And don't worry about it. for this one in particular, there's no horizontal asymptote. We can also talk about the range and the domain. Domain, we will have to solve the inequality, so maybe later. All right, let me see. Solve the equation x to the 3 plus 1 over ln(x). I don't think that's... I don't know if that's quite possible. Is x equal to e? No, that's not e. No, sorry, I can't tell. I can't do that right away. Log of 0 is equal to negative infinity. That's when you are talking about limit, though. According to decimals, I think it's just because they want to indicate the behavior of what's happening. Right here, in general, log of any base b of 0, this right here is undefined. This is actually pretty good because there's no even argument about this. Remember 0 to 0, this right here has no agreement. Like some people say it should be 1, some people say it should be undefined. No, it has no argument. This is better because it's just undefined. Nobody will argue with you. Well, if you're saying the limit, which is like the behavior, okay, as x approaching 0 from the right hand side, like this, of ln x, this you do get negative infinity. And in precalculus, you do start have to learn about limit and the behavior because we want to talk about the situations that we cannot do. We cannot plug in 0. So what if we try to approach 0 and the output of the y value, you can see that the graph goes down, and that's the idea of the limit. Sometimes some books, they just use limit right away. Sometimes some books, they use the phrase behavior, right? I think behavior is a very good way to introduce students the idea of limit. What's the behavior of ln x as x approaching 0 from the right hand side? The plus means the positive direction. So positive, and we're approaching 0, and you can see the behavior of the function. It goes straight down. So we have negative infinity. X to the third power is equal to 2 ln of 1 over x. I don't think that's solvable with like regular things. Maybe you have to use some like high-tech stuff, right? But here we're trying to just keep everything in terms of trig and precalc. And today our focus is on logarithm. So if you have any questions regarding log or anything that you would like to discuss, feel free to let me know. And I can kind of tell if a question is solvable or not without using anything too high tech, right? So if you're asking a question that I don't think is solvable with like usual method, then unfortunately we cannot do that. All right, thank you guys so much for coming today though. We do have about like 12 minutes left. This live stream is brought to you by Chegg. And we will be back next week, trig and precalc. So if you don't think the next 10 minutes is enough for you, make sure you just come back next week, 6:45 p.m. to 7:45 p.m. We will be doing this until the end of May. And definitely scan the QR code and subscribe to Chegg's YouTube channel so that way you can be notified with the office hour that we have. Okay, so let me just see. Still 10th grader here. Where should I start to get better at these things? So if you're talking about math in general, firstly, I'm going to assume that you are comfortable with the things that you learn in school and just want to learn more. If that's the case, let me know. If not, then of course I will recommend you to do well in school first, right? It's the math class that you have in school, and then just kind of make sure you follow what your instructors, what your teacher told you to do and work on, and follow the curriculum. So definitely focus on that. If it was the first case that you just want to learn more, then definitely there are a lot of online resources nowadays. You can Google them, and definitely you can come back and ask me questions for this. And then also, if you have a textbook, right, the Precalculus textbook, you should be able to find some sections that has that challenging questions, so you can be really good at it. But if you want to build a foundation, then definitely know the fundamental. Today we are talking about logarithmic equations, but you will notice a lot of the concepts are from earlier, such as factoring, horizontal, vertical isotopes, and also the graph that we have right here, right? This is what graph is this? And then I can't do the graph if it's just like one hand. There you go. Okay, this is exponential. This is logarithm. One of the most important things to learn better, to get better at math, is that you have to make sure you have a strong foundation. Because otherwise, the new materials will be like nearly impossible. All right, so keep that in mind. Keep that in mind. Why is E called natural? What makes it natural? Very good question. I can't really tell you why it's called the natural, why they use this word natural. But let me just write this down. This is the natural log. And the key right here is just that ln means you have log base E, and E is approximately 2.718. What makes this natural? That I am not entirely sure because the word natural, but I can tell you a few properties about about the number E. And that is perhaps you can just think about it as like cool enough and all that to make it natural. One thing is that in terms of talking about exponential functions, there will be plenty of times, enough times, many times that you use e for the base rather than 2. You can use 2, that's like doubling, but if you're talking about continuous growth, it's about the base e. Even though you can rewrite it, but that's kind of like almost like cheating because it's like if you see the base 2, you can purposely write it as e to the ln 2. So you can always use the number e for the base. So it's like, I don't know what to say in that regard. But anyways, though, here, let me see how much time we have. That was 7 minutes. One of the things that you can do is, here's the compound interest formula. If you compound something n times, then you end up with this. The amount equals the initial amount times 1 plus the rate divided by however many times you compound in a year, raised to the total number of times that you are considering the compound. So it's NT. Let's say if you compound 10 times a year, and then n is equal to 3, that means 3 years. Here, it will be 30 because you are doing the compounding thing 30 times. So this is the compound interest formula. But if you put R, if you take R to be 100%, right? And then just say T is equal to 1, like 1 year. And you can also take the initial to be 1, just like you can imagine this is like you have $1 or something. Then the amount is just 1 plus another 1 for the R, and then n is 1, and n, and then t is 1. So it's like this, which is just this portion. Agree? This is the compound interest formula if you consider nice numbers. Usually these parameters is that, okay, this is the real deal right here. The interesting part is that if you compound it enough time in a year, by enough I mean infinitely many times, this is going to be approaching the special number e. Let's see if we have some space. N and then 1 plus 1 over n raised to the nth power. I do have my notes from my class. I did do this right here on the other day. So let me look that up with the numbers so I don't have to use a calculator. So this way we can have more time. All right, cool. So here's the deal. Imagine if you compound 100 times, then the result is going to be 2.7048. So that's 100 times. And if you do it enough times, let's say if you have, let's say 100,000 times. By the way, in the chat, go ahead and think about this. What's something that you do like continuously on everyday basis? Is there anything that you can do 100,000 times in a year? I asked this question with my students many times whenever I go over this topic. Can you think about something that you do pretty much every day continuously? In the meantime, I'm going to write down the answer. This right here is about 2.718, 268, and so on, so on, so on. So if you really do it infinite times, if n goes to infinity, you will get a number. It's about 2.718. I don't have enough space. Usually should get more numbers. You get e. And we use the label e to denote the number 2.7182818. By the way, it's 4590. It does not repeat. This is an irrational number. Okay, let me see. Okay, yes, breathing, right? How many times do you guys breathe a day? I asked my pre-calculus students, and it's a lot of fun when we talk about that. How many times do we breathe a day? Blinking is not as often as we breathe, though, because when we sleep, we don't blink, right? But when we sleep, we still have to breathe. So that's continuous. So imagine if you just compound something the moment you breathe. So that's almost like continuous. You see, I don't have to blink for like 10 seconds, but I have to breathe like rather continuously. You guys can Google it or something and let me know how many times do humans breathe on average per day and then per year. This is how I like to think about it. I just tell my students that imagine for this formula, it's like I calculate the compound the interest for you every time you breathe. If you do this $1 at 100% after a year, you will end up about $2.7. Yeah. And then again, like base E, is it always base E? Because you can always write something like this, right? And the cheating part is that this is also log base E. E is about 2.718. So you can always write any base in terms of base E, but E does show up. Like this is the coolest part about E, right? About 22,000 times a day, and then multiply by 22,000. That's a lot. Really? Heartbeat. Oh yeah, either heartbeat or breathe, but I cannot really Since I heartbeat, I cannot count. Okay, heartbeat will breathe. Okay, thank you guys so much for coming here today, though. It's time, but we will be back next week, Monday, from 6:45 p.m. to 7:45 p.m. Today was great. Thank you guys so much for coming, and thank you guys so much for your questions. Remember, next time, Chegg will bring you guys back the Trig and Precalculus office hour, and I'll see you guys then.